Video, I'm going to solve the following problem for you. This is a problem in linear algebra on the topic of invertibility of matrices. Let me read the question for you first. Let A and B be square matrices of order n such that In minus A times B is invertible. Show that In minus BA is also invertible and determine its inverse in terms of A, B, and the inverse of In minus AB. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the problem correctly, what you get for the inverse of this matrix is given by this relation. But I recommend you do not use this answer to prove this problem, because one easy way, of course, would be to multiply this matrix by this matrix and to show that this is equal to the identity matrix. Then it means that you have proven the invertibility and you have also shown that this is the inverse. But assume that the answer is not proposed to you and you still want to prove the invertibility. Okay? Now, let us try to solve the problem. Usually, the criterion that comes to mind when we want to talk about invertibility of a matrix is the determinant criterion, meaning that if the determinant of a matrix is not equal to 0, then it means that this matrix is invertible. Okay? But here, probably this is not very promising, because I do not have any formula to calculate the determinant of this and show that this determinant is not equal to 0. But there are other ways that we can guarantee invertibility of the matrices. One of them I want to recall you from your linear algebra course. So assume that you have a matrix, call it M. You want to show that M is invertible. One way is, of course, to calculate the determinant of M, which will not work here. What I'm saying is that you can just multiply this by a column matrix X and equate it to 0. If this implies that X is equal to 0, this means that this homogeneous system of equations has only the trivial solution X equal to 0. Then this would imply that M is invertible. Okay? So I would say that if this implies that, then from here you can conclude that M is invertible. So I want to use this for solving this problem. Okay. Now I want to show that this matrix is invertible. According to this criterion, what can I do? I can apply this matrix on a column matrix, call it X, equals to 0, and ask myself, can I conclude that X is equal to 0? If the answer is positive, then it means that this matrix that you see here is invertible. Okay, so let us see how can we do that. Of course, I need to relate this problem somehow to invertibility of this matrix. Okay, let us just start. I would say that In minus BA X is 0. I can distribute this because we know that matrix multiplication enjoys the distribution property. So this becomes In times X minus BA times X is 0. But In times X is just X itself. And here I can write it as minus BAX. And I can remove a pair brackets because I know that matrix multiplication is associative, so I really don't need to prioritize which one of these products has to be done first. Okay, so then what happens? I will have 0. Then what I can do, I can write something here for the future. So this means that X is equal to B times AX. Okay, I will need it for the future. So let me just keep it here. So I just moved this one to the right hand side and put them in the pair of brackets. Okay, so this means that X is equal to that. But now I will continue in this way. I want to multiply both sides by matrix A from the left. Okay, so I will multiply both sides by a, so this becomes ax, and the other one becomes a b ax. On the right hand side, of course, a times the 0 matrix is the 0 matrix. The reason that I don't worry about putting pair of brackets, because I know that matrix multiplication is associative. But what is good point about this, you see that I have ax here and I have ax here appearing on the right hand side in this product. So I can take this ax out, factor it out, but I have to respect the order. And I have to factor it from the right. So it becomes in minus ab, and then I have ax. On the right hand side I will have 0. So if you want to double check, multiply this back here, it gives you this, and multiply this back here, this gives you ab times ax. But now this combination is this combination that it is guaranteed to be invertible by the problem itself. Okay, so I have this multiplied by a column matrix, because this matrix is a square matrix. When you multiply it by a column matrix, this is also column matrix. A matrix which I know is invertible multiplied by a column matrix, let us call it y, and this is equal to 0. This implies that y is equal to 0. So this implies that, so let me write it here. Yes, so I can write it here. In minus ab is invertible. This implies that ax is equal to 0. Okay, so do you remember now? I can use this number, let me call it number 1. So here I can conclude that using number 1 that x is equal to 0. Yes, because if you take ax out and put the 0, x becomes 0, and then that is your goal. Yes, do you remember? My goal was to show that x is equal to 0. So this proves very simply the invertibility of this matrix. Okay, and now according to the problem, I'm supposed to determine its inverse in terms of AB and the inverse of in minus AB. So what can I do? I would say let the inverse that I am looking, let me give it a name. I want to give it a name, and I want to find C in terms of A, B, and the inverse of, I have to replace these two. BA. I want to find the inverse of this matrix. I call this C, and my goal is to find C in terms of A, B, and the inverse of this matrix, which was guaranteed from the beginning. I want to write the inverse of matrix in terms of these matrices. Okay, so what can I do? When you say that the inverse of matrix in minus BA is C, it means that if you multiply these matrices, this would be the identity matrix. And now let me just multiply that, so it becomes C minus BAC. On the right hand side I will have AN. Okay, and then what I do, I multiply both sides by A again here, so this becomes ABAC. On the right hand side I will have A. Okay, and then what I can do, I can factor AC out from the right, exactly the way that I did it before. So this becomes AB, and then I will have AC, and then I will have A. Yes? So what happens here? I multiply both sides of this relation by the inverse of this matrix. So this becomes AC. On the right hand side I have to write AN minus AB inverse multiplied by matrix A. Okay, so this is what I got. But be careful, I am not allowed to multiply by A inverse to get C, because this is not guaranteed by the problem that A inverse exists in the first place. We only know that this matrix is invertible. We don't know about invertibility of matrices A and B. Okay, now what can I do? I can go back here and then use this relation to find C. So C is equal to IN plus BAC. I moved minus BAC to the right. And now, instead of this AC that you see here, I want to replace this expression and then I will be done. So this means that C is equal to IN plus B times AC, but AC is just this expression. Yes? And then what is written here is that this is your C in terms of those matrices asked in the problem. Yes? So what I have done, I just used this fact, I wrote it in this form. I already got AC to be this, so instead of AC, I put the whole expression here, and then I wrote the answer. So you see immediately that this is the inverse of your matrix. I was looking for C, and I got it. Okay? Of course, if the answer is provided for you from the beginning, you don't need to be very creative. Whenever the inverse of a matrix is proposed in the problem itself, what you want to do, what you need to do to prove both invertibility and proving that this proposed inverse is the correct one is to just multiply these matrices. Okay, so let me just do this problem in this way as well. So what I want to show that, let me change my color here. I want to show that if I take AN minus BA and multiply it by what is proposed in the problem as the inverse of my matrix, I get the identity matrix at the end. Okay, so let us see how can we calculate that one. I would recommend to take this one. I think it's better to take this one, cut, and then start on a new page so that we have enough space to see what's going on. Okay, so here I want to show that this is equal to IN. So I would start from the left hand side and start multiplying these term by term. So this term by that, this term by this, and then this by that, and this by this. Be careful, you have to keep the order. So IN times IN is just simply IN. IN times the second term is just the second term. And then minus BA times I becomes minus BA. And then minus BA times the other matrix, you have to keep the order here, it's crucial. Minus BA times B IN minus AB to the minus 1A. So that's the way that you have to multiply them. So let me rearrange them. I write IN first, I write minus BA second, but between these two, I want to factor something out properly so that we can give me the solution. Okay, so here I will factor a B out from the right, from the left, and the whole expression IN minus AB minus 1A from the right. So let me just explain. Concentrate here and here. So here B, here and here are on the left. I am pulling B from the left from these two, and I am taking this expression which is here from the right. So you see that what is left for me. The identity matrix will be left from here, and then I have minus. So let us repeat this one. I pulled this one out, I pulled this one out, so minus AB is left. But that is very interesting now because this is exactly the combination that I need. You see now, these two matrices are sitting next to each other, and one of them is the inverse of the other one. So what I will get is that this is nothing except the identity matrix IN. And then this B times IN times A is just BA. So this becomes IN minus BA plus BA. And then finally this becomes IN, and this is equal to the right hand side. Okay, as I told you, but the goal of the problem was not to do this. Whenever the inverse of a matrix is proposed in the problem itself, it shouldn't be that hard to confirm that proposed inverse is actually the correct one. And of course, if you find the inverse, it means that you have already shown that this matrix is invertible in the first place. Okay, so I hope that this video is useful. Below the video you will find the link to the PDF file of these notes. Until the next video, be safe and goodbye.